Hi everyone, good morning again. I hope that everyone is doing fine right now. So welcome to Math 036 Plain and Solid Geometry. So today we are going to tackle about lesson number 21, which is entitled The Area of a Triangle, a Quadrilateral, and Irregular Polygons. So who are the reporters for this morning? Syempre, yours truly, Sanime B. Caballan. With me are Mr. Brian Baculio and Miss Maria Hanigrace Dato. So to begin with, let us first start with our lesson objective for this morning. So our target for this morning is you are all expected to apply the area formulas for triangles and quadrilaterals. Second is you are all expected to solve problems involving the areas of a polygon. And lastly, you are all expected to solve for the areas of a composite figures. So now, area of a polygons. What comes into your mind when someone asks you what is an area? Area is the amount of surface enclosed by a closed two-dimensional figure. It is measured by the number of unit squares it takes to cover a two-dimensional shape. So now, let's start with the area of a triangle. First is knowing the base and the height. I know that this knowing the base and the height was kind of easy. It's just simply the half of base times height. If we already have the base and the height, we can now simply calculate the area of a triangle. So this is the formula of knowing the base and the height of a triangle. For example, 12 is the height, not the length of the left-hand side. So as you can see in the figure, there is the measure of our base, which is 20, and our height is 12. So we're just going to substitute that one. That would be 1/2 times 20 times 12 is equal to 120. So which means that the area of this triangle is 120. So aside from knowing the base and the height, we also have knowing the three sides. There's also a formula to find the area of any triangle when we know the length of all three of its sides. This can be found on the Heron's formula. Are you familiar with Heron's formula? If no, then you search. Charot. In area of a triangle from sides, you can always calculate the area of a triangle if you know the length of all the three sides, using, like what I said, Heron's formula. Just a little background of Heron's formula. Heron's formula was written in 60 CE by Heron of Alexandria. It was this formula has been known for nearly 2,000 years now. It's after Hero of the Alexandria, like what I said. He was a Greek engineer and a mathematician who determined the value of an area of the triangle using only the length of its sides and further extended it to calculate the areas of a quadrilateral. There are two steps in calculating this one. First is calculate the S, which means half of the triangle's perimeter. So that would be S is equals to the quantity of A plus B plus C over 2. Second is you can now calculate the area. If you already have the half of the triangle's perimeter, you can now calculate the area, which is area is equals to the square root of S times the quantity of S minus A, S minus B, and S minus C. So that one. For example, I have here, what is the area of a triangle where every side is 5 long? So now we'll just first calculate the S. 5 plus 5 plus 5 over 2. So that would be 7.5. Since we already have now the half of a triangle's perimeter, we can now calculate the area of this triangle. So that would be the square root of 7.5 times 7.5 minus 5, 7.5 minus 5, and 7.5 minus 5. We're just going to simplify that one. That would be square root of 7.5 times 2.5 times 2.5 times 2.5. Simplify again. That would be square root of 117.8 and 75. And the square root of this 117.8 and 75 is 10.825. So therefore, the area of this triangle is 10.825. So there. Aside from knowing the base and the height, knowing the three sides, we also have the last one, knowing the two sides and the included angle. When we know two formulas and the included angle, SAS or the side angle side, if I'm not mistaken, there is another formula. In fact, three equivalent formulas we can use depending on which sides and angles we know. The formula can be written in three ways. These are: area is equals to 1/2 times AB times sine C, or area is equals to 1/2 BC times sine A, or area is equals to 1/2 CA sine B. So there. We have here an example. Find the area of this triangle. We have here a triangle CAB, where angle C measures 25 degrees, sides A measures 7. Sides A measures 10, that would be wrong. 10 and B is 7. There. Namali siya. I'm sorry. So, we will use this formula. Area is equals to 1/2 AB sine C. Substitute, that would be 1/2 times 7, times 10 times 7 sine 25 degrees. That would be 35 times 0.2422. So, we're just going to simplify that one. That would be 14.8. So, therefore, the area of this triangle measures 14.8. So, there. Just always remember the formulas lang dyan siya para ma-solve mo, para alam mo kung paano siya i-solve, paano kunin yung area ng triangle. So that would be all. I hope na you learned something and then you enjoy watching this one. I will give now the floor to Mr. Brian Bacolio so that he could explain furthermore about the area of a quadrilaterals. Thank you and God bless. Bye!
Thank you, Miss Sunny, and again, good day. I'm Brian Bacolio from FINMA Cagayan de Oro College, and I'll be discussing the quadrilateral. In our previous lessons, one of our classmates discussed the properties of quadrilateral, and now I'll be discussing the area of quadrilateral, or how to get the area of quadrilateral. What is quadrilateral pala? So, it is a four-sided polygon, the sum of whose interior angle is 360. So, again, quadrilateral has four sides, and of course, it has four angles that equal 360 degrees. So we have 6 types of quadrilateral. So, and it has a specific formula in each shape or type. First, we have square. So the area, the formula to get the area of a square is A is equal to S squared, where A is the area and S is the length of the side of the square. So, for example, the length of our square is 5. So you just substitute the value of you just substitute the value of our or the side of the square. So we have A is equal to 5 squared, and 5 times 5 is equal to 25. Therefore, the area of our square is 25. Next, we have rectangle. So the formula to get the area of the rectangle is A is equal to L times W, where L is the length and W is the width of the rectangle. So let's say the length of our rectangle is 9 and the width is 7. Since it's so 9 times 7 is equal to 63. Therefore, the area of our rectangle is 63. So the third one is parallelogram. So the formula to get the area of parallelogram is A is equal to B times H, where B is the base, the parallel base, and the H is the height of the parallelogram. Now, let's say the height of our parallelogram is 7, and the base of the parallelogram is 9. So 9 times 7 is equal to 63. Therefore, the area of our parallelogram is 63. Fourth, we have trapezoid. So to get the area of the trapezoid, we have this formula. A is equal to 1/2 times H times B sub 1 plus B sub 2, where 1/2 is constant, H is the height of the trapezoid, and B sub 1 and B sub 2 are the parallel base of the trapezoid. For example, so the B sub 1 is 6 and the B sub 2 is 9, and the height of our trapezoid is 8. So we have A is equal to 1/2 times 8 times 6 plus 9. So 6 plus 9 is equal to 15, and multiply it by 8 and multiply it by 1/2, so we have 60. So therefore, the area of our trapezoid is 60. So and to get the area of the rhombus and kite, they have the same formula. So the formula is A is equal to 1/2 times D sub 1 times D sub 2, where 1/2 is constant and D sub 1 and D sub 2 are the diagonals. So let's say the diagonal 1 is 5 and the diagonal is let's say 6. So 1/2 times 5 times 6. So 5 times 6 is equal to 30, and times 1/2 it equals to 15. Therefore, the area of our rhombus or kite is 15. So yun, I hope you learned something from me, and that would be all. Thank you. Happy watching.
So, salamat Sunny. Good morning everyone. I'm Mariahani Grace Aidatu, and today let me share with you the regular polygon. So, a polygon is a plane shape, two-dimensional with straight sides. Example for this includes the triangles, quadrilaterals, pentagons, hexagons, and so on. So, sa regular polygon, it has the all sides equal and all angles equal. So, we have the example of regular pentagon. So, in regular pentagon, we have the 5 sides, and that 5 sides is equal, and the 5 angles are equal din. So, pag regular polygons, dapat ang angle at saka ang side is equal. So, the properties of regular polygon. So, ang properties sa regular polygon may dalawa. We have now the exterior angle and the interior angle. So first, we're going to define first the exterior angle. So, The exterior angle is the angle between any sides of a shape and a line extended from the next side. All the exterior angles of a polygon add up to 360 degrees. So, lahat ng exterior angles sa polygon dapat mag-total siya ng 360 degrees. So, each exterior angle must be 360 degrees divided by n, where n is the number of sides. So, for example, the regular pentagon. Regular pentagon has the total of the 360 degrees each exterior angle of regular pentagon. So for example, we have the exterior what is the exterior angle of the regular octagon? So sa regular octagon, meron tayong 8 sides. So we're going to solve this one. Exterior angle is equal to 360 degrees divided by n. So 360 degrees divided by our n, ang ating n dito is ang 8 sides sa octagon. So 360 degrees divided by 8 is equal to 45 degrees. So lahat ng exterior angle sa regular octagon has a 45 degrees ang exterior angle. So, sa regular polygons naman, di ba, may exterior, may interior angles din. So, sa interior angles is the interior angles and exterior angles are measured from the same line. So, they add up to 180 degrees. So, sa exterior angle, nagtotal siya ng 360 degrees. So, sa interior naman is 180 degrees. So, 180, so sa interior angle is equal to 180 degrees minus the exterior angle. So, pwede naman natin yung ma-rearrange. Gaya nito. So, exterior angle is equal to 180 degrees minus 360 degrees divided by n. So, n multiplied by 180 degrees divided by n, close open parenthesis, minus 2 multiplied by 180 degrees divided by n, close open parenthesis. So, ang formula ng interior angle is n minus 2, close open parenthesis, multiplied by 180 degrees divided by n. So, meron na tayong formula ng interior angle. So, for example, sa interior angle is, what is the interior angle of the regular octagon? So, di ba, nalaman na natin kanina na ang regular octagon has 8 sides. So, we're going to solve first the exterior angle. So, exterior angle is equal to 360 degrees divided by 8 is equal to 45 degrees. So, the interior angle now, kasi nakuha na natin yung exterior angle eh. So, susunod natin isosolve is ang interior angle. So, interior angle is equal to 180 degrees divided minus 45 degrees is equal to 135 degrees. So, pwede naman natin yung gamitin yung formula talaga ng interior angle. So, interior angle is equal to n minus 2, close open parenthesis, multiplied by 180 degrees divided by n. So, we have now the 8. Our n here is 8. So, 8 minus 2, close open parenthesis, multiplied by 180 degrees divided by 8. So, 8 minus 2, we have 6, multiplied by 180 degrees divided by n, 8. So, we have here the 135 degrees. So, they have the same answer. So, each interior angle of the regular octagon has 135 degrees. So, what if pag ang interior at saka exterior angles ang hinahanap? So we have here the regular hexagon. So a regular hexagon has 6 sides. So first we're going to find the exterior angle. So exterior angle is equal to 360 degrees divided by 6 is equal to 60. So the interior angle now, ang susunod nating isosolve, interior angle is equal to 180 degrees minus 60 degrees is equal to 180 degrees. 120 degrees. So if we're going to add the exterior and interior angles, may total tayo na 180 degrees. So sunod naman nating itatakol is ang circum circle, incircle, radius, and apothem. So circum circle is the outside circle is called the circum circle, and it connects all vertices, corner points of the polygon. So radius of the circum circle is also the radius of the polygon. So ang incircle naman is the inside circle is called the incircle, and it just touches each side of the polygon and its midpoint. So ang apothem naman is the radius of the incircle is the apothem of the polygon. So ito yung larawan. Circum circle is the outside circle sa circle nga nag-connect sa lahat ng vertices sa polygon. So ang incircle is ang parang siyang inside circle sa polygon. Tapos alam naman natin yung ang radius is same lang sa yung nalaman nating radius na from center to the each point sa corner points sa lahat ng points. Ang apothem is the radius of the incircle of the apothem and the polygon.
Feel like teenage Mona Lisa, so beautiful yet so unsatisfied.